Okay. Late night math. Late night math. Let's do this. The question is, what should we work on until somebody comes up and says, hey, I have problems? Right? What should we work on? You guys are way up there now. Oh, I gotta turn that on. Huh. Big Blue? Okay. Let's see if we can figure out some vector calc. I am not very good with the stuff that I'm going to do ahead of time. So I'm just going to do it now until somebody shows up. Ah, there we go, our vector calc. So truth be told, I've been going through all my old textbooks and stuff and relearning stuff. So I don't know all the answers. I never did. I wasn't that smart. But I'm one of those SMRT people, you know, the ones that are semi-SMRT. So let's continue figuring out what we're going to do. 2.5 vector calc. We already did that one. We're going to do D now. D. Should we do it in blue or should we do it in black? Blue doesn't look that bad. Yeah, I could do it this way. Yeah, let's do it in blue. So I've got f of xy is equal to x e to the x squared plus y squared. And we've got c of t is equal to t and minus t. Okay. What we need to do is basically just do the chain rule. We're verifying the chain rule. We've got FOC, which means we're going to take f of c of t. And we're going to find the derivative of it. So what's the chain rule? Chain rule is we've got d by d, what is it, t of f is equal to d by d f of x dx dt plus df dy dy dt. Okay. Let's verify that that's the chain rule that we're supposed to be working with. dx dt, good. df dy dt, dy dt, good. Okay. Let's see what df dx is. Well, our f with respect to x. We need to find the derivative of f with respect to x. So df dx is what? We've got, well, it looks like a product rule again. So we've got fg product is fg prime plus gf prime okay. So if x is our f derivative, we have just an x in front. Derivative of e to the x squared plus y squared, we hold y squared constant. So we would have e to the x squared plus y squared. And then the chain rule of standard, how do I want to say, non-multivariable, singular variable, would be a 2x in front, because you take the derivative of f squared. Okay. Then we have plus g, which is our e to the x squared plus y squared, multiplied on the derivative of f. Well, the derivative of f is 1. So we're done. What is derivative of x with respect to t? In C of t, this is our x value, right? And this is our y value in the coordinate system. So derivative of t with respect, derivative of t with respect to t would just be 1. And then we need d f with respect to y. And what is that? Well, we only have the y variable up here, and x is constant. So we don't have to mess with much. It's just 2yx e to the x squared plus y squared. Not too hard, not too hard. Okay. Now, we need derivative of y with respect to t. What's the derivative of y with respect to t? We've got -1 this time. So let's plug it all in. df dx is this whole shenanigans. X e to the x squared plus y squared. Well, this is actually 2x squared if we simplify it. Then we have plus e to the x squared plus y squared. I'm gonna leave this like this first instead of factoring, just in case it makes it easier later. We'll see. Dx dt, which is 1, so just times 1. We don't have to write it, but whatever. Plus df dy, which would be 2yx e to the x squared plus y squared, and then multiplied by dy dt, which is -1. So I'm just gonna change this to a negative. Okay. This one, we don't really matter, so we'll get rid of it. So then this, let's take out an e to the x squared plus y squared, because it's in common with all the other, what's the word I want to use? Components. So what are we left with? We've got 2x squared minus 2yx. So here's this one, and plus 1, acting on e to the x squared plus y squared. Okay. Now we did it one way. We have to look and see about doing it the other way. Verify, right? So in the first one, we did the chain rule stuff. Now we're going to do the composition. Put c of t inside for x and y. Okay. I'm going to slide this over and do it on the side. So, c of t inside. So wherever there's an x, we're going to plug in a t. Wherever there's a y, we're going to plug in negative t. Okay. So f of c of t is, well, x we're going to turn into a t. We got e to the t squared for the x, and then y is what? Y is negative t, so that's going to be plus t squared. So this will equal t e to the 2t squared. It looks right to me so far. What are we doing again? Oh, right. We need to plug it into, with respect to t. That's right. Right. Okay. Cool. We actually didn't finish the bottom one, but we'll get to it in a second. So what is the derivative of this with respect to t? Well, we use the product rule again. T times what? Just says 4 t e to the 2t squared plus e to the 2t squared times 1. Well, this equals 4t squared plus 1 acting on e to the 2t squared. Okay, let's go back. Now wherever there's an x, we plug in t, and wherever there's a y, we plug in negative t. So we've got 2t squared minus, well, there's a negative in this, so y makes this negative, so this is positive. 2t squared plus 1 e to the t squared plus t squared. Oh, look at this. You add those together, you got 4t squared plus 1 acting on e to the 2t squared. They are the same. Oh yeah. Now, should I write it down? Yeah, I probably should. I was planning on doing it. Give me a second here. Where did my... Where did it go? Back in a jiffy. There we go. I'm actually just using a music stand as my note stand. So I'm going to write this down. And as I write it down, I'll kind of re-explain it. Go back. Make it look semi-nice. Okay. First, we have this function, f of xy equals x e to the x squared plus y squared. And we had c of t equals to t and negative t. So our objective in this question was to verify that the chain rule works, both with the composition and the way the chain rule writes down. So first we write down the chain rule. So we get df dt is df dx times dx dt plus df dy dy dt. And then we take the derivative of, we find our derivatives. df dx would be x e to the x squared plus y squared times 2x plus e to the x squared plus y squared dx dt equals 1 df dy equals 2y x e to the x squared plus y squared, and dy dt is negative 1. Okay, let's start. Then we plug in all our derivatives into our chain rule. 2x squared e to the x squared plus y squared plus e to the x squared plus y squared. And remember that was multiplied onto 1, so we just didn't bother with it. And then the negative 2y x e x squared y squared, which equals 2x squared minus 2yx plus 1 e to the x squared plus y squared. And if we plug in t and minus t for x and y, we get this. Okay. 4t squared plus 1 acting on e to the 2t squared. And since I did it on the side, we've got f of c of t is t e to the t squared plus t squared, or t equals 2t squared. E to the 2t squared. Try to say it right. So then you got t 4t squared plus 1. And this is acting on e to the 2t squared. Verified. Okay, next question. Go back to the side, make sure our thing looks okay. What's our next question going to be? Let's do this one from the book. It says, what is the velocity vector from part B of the last question? Well, we have the answer. I'm going to just write it down. 5b. So our derivative was 15. Well, first our f of xy is e to the xy And our c of t, yep. 3t squared, comma t cubed. And after our chain rule, we got I'm going to say df dt is 15 t to the 4 e 3t to the 5. Okay. It wants to know what the velocity vector is. To find the velocity vector, we take the derivatives of each component of c of t. So, c of t prime. Well, 3t squared, the derivative of that is 6t. 6t. And then t cubed, which would be 3t squared. That's an easy question. I don't know why they made us do it. I wonder if there's a part in the textbook that would maybe explain why that would be the velocity vector. Ah, the mapping. Okay, cool. Anyways, I'll write that down quick. We'll move on to a different type of question. Okay, this one I'm not gonna know for sure how to do. We'll just do it. See if we can find the answer. This one is let Rf go from R3 to the reals and G, oops, that's not an and. G go from R3 to the reals, be differentiable, we want to prove that the gradient of f times g is equal to f times the gradient of g plus g times the gradient of f. Now, let's see. Is there going to be I was looking for a theorem. Okay. So the theorem in the product rule states that we have these same kind of differentiable functions, but they're 1 by n matrices. Okay. So product rule states using Rn to R, and they have d h of x0 equal to g of x0, d of f of x0 plus f of x0 d times g of x0. This is a 1 by n matrix on both sides. But we want just R3, and thing about the gradient. Oh, I am having a hard time breathing for some reason. Okay. The gradient is what? It's just the derivative of each particular thing. I wonder if there's a standard way to write it. Whatever. I'm going to write it as this matrix. D by dx, d by dy, d by dz. You get the picture. If we use vectors instead of matrices, then we would get this case. Just by the chain rule. Yeah, just by the product rule theorem. It's not really much of a question. Literally, the answer just says replace matrices with vectors in the theorem. And that's how you get it. I don't like it. Let's do another one. Okay. Let's do the next one. Well, this is a little more calculable. We've got f of u comma v is equal to tan of u minus 1 closed minus e to the v comma u squared minus v squared, and g of xy is equal to e to the x minus y comma x minus y. Calculate f of g and d of f of g at 1 comma 1. Okay. So we're just doing composition and derivative of the composition. Not too big of a deal. So f of g. So g inside f. So otherwise known as f of g of xy. Okay. I'm going to plug in g of xy. So for every u, so this would be our u value and this would be our v value. For every u, we're going to plug in e to the x minus y. So tan e to the x minus y minus 1 minus e to the x minus y, comma, u is e to the x minus y, and this is squared. So e to the x minus y quantity squared, we'll distribute it after, and minus v squared. V is x minus y, so x minus y squared. Okay. By the way, this is my first time doing this question too, so bear in mind if I get it wrong. Okay, what's next? Is that what it wanted? Yes, that is what it's wanted. And the only other thing is, I guess I could write this a little smoother. Put the 2 right here. There. It's a little smoother. Stop me anytime if you want to do your own questions and stuff. Now, we want to find the derivative. Well, how do we do this? This ends up being a 2 by 2 matrix. Okay. And this is a vector, and this has 2 component points. We're going to have d of f o g is going to be, well, there's a derivative of the first component. So d, what is this? Du dx, and derivative of the first component with respect to y. Derivative of the second component, dv dx, and dv dy. I'm going to make sure that I wrote down the matrix properly. Yes. Brilliant. Okay. Which means, what is the derivative of the first part with respect to x? Ugh. Okay. Du dx. Well, what is the derivative of 10? Is it 1 over 1 plus x squared? Something like that? Reference sheet? Nope, derivative of 10. I'm thinking of 10 inverse or something. Yeah, I'm thinking of 10 inverse. Secant squared. So, secant squared of e to the x minus y minus 1 multiplied on the derivative of the inside with respect to x, which is just e to the x minus y, and then minus derivative of this with respect to x, which is just itself, minus e to the x minus y. Okay. Now, du with respect to y. I should write partials, but it's a little easier to write just regular, I guess. Okay. Du with respect to y. It'll be the same thing, but there's going to be a negative sign changing in here because the y is negative. Okay. Secant squared e to the x minus y minus 1. And then there's going to be a minus from the derivative of the inside. And e to the x minus y. And this is going to be a plus e to the x minus y. Because the derivative of e to the x minus y, using the chain rule, we got the -1, we bring it down. Negative times a negative is a positive. Okay. dv dx. Okay. This is our v. This was our u. This is our v. Okay, derivative of v with respect to x. Well, this should be a lot simpler. Just 2e to the 2 times x minus y minus this with respect to x. The 2 comes down, x minus y, 1 minus 1 from the exponent, and multiplied by the derivative of the inside. There's nothing to play with. Done. Easy. Okay. dv dy. Okay. How are we going to do this one? Pretty much the same thing, but now there's negative signs involved. This will just be negative 2e to the 2x minus y. Okay. This one, look, the 2 is going to come down, and then you multiply the derivative of the inside, so the derivative of negative y is just negative 1, so the negatives will cancel out, so this would be a plus 2x minus y. Now we'll make the matrix. So, where should we start it? Right here. Good enough. du dx, we're gonna take out a e to the x minus y. Might as well, right? We've got secant squared of e to the x minus y minus 1, and then minus 1 e to the x minus y. That's du dx. Du dy, we've got the negative of that, so I'm going to go 1 minus secant squared of e to the x minus y minus 1 multiplied by e to the x minus y. Oops. Now, if anybody watching wants to stop and do their homework, just let me know. I'm just doing my homework for now, and my homework is whatever I make it to be. dv dx is this one. We've got 2e to 2x minus y, and then minus 2 times x minus y, and dy dv negative 2e 2 times x minus y plus 2 times x minus y. Okay. Not bad. Let's see, is that the right answer? I don't know. That was the first time doing this question. Oh, right. I forgot about the point. You'll have to plug in the point. What is the point? 1, 1. Okay. Now we're going to plug in the point. 1, 1. Could have plugged it in earlier, but here is good enough for now. Okay. Secant squared of e to the 1 minus 1 is 0. So e to the 0 is 1. So we've got secant squared of 0 minus 1 times e to the 0. And then this one here is, well, we got 1 minus secant squared of 1 minus 1 is 0. E to the 0 is 1. 1 minus 1 is 0. Okay. And then this is multiplied by e to the 0. Okay. The next one, we got 2 e to the 2 times, well, 0. And then this one, we've got, well, minus 0. 2 times 0. Then we've got minus 2. And e to the 2, 0. Then we've got plus 2 times 0. Gives us what? Secant squared of 0. What is secant squared of 0? Well, what is secant of 0? Secant is 1 over cos, right? Cos of 0 is 1. So this is 1 squared minus 1. So this is 0. And, well, again, this is 1 minus 1. So this is 0. And this is 2. And this is minus 2. So our final matrix will be 0, 0, 2, negative 2. There we go. That was our whole matrix. We did all that work from there. Okay, let me write it down. Do. Anybody have any homework that they want to do? Or any questions or any relevant topic that involves some form of math? Something to just talk about? Anybody? You tell me. What am I doing here? F of uv equal to tan of u minus 1 minus e to the v, u squared minus v squared, g of xy equals e to the x minus y and x minus y. How is the YouTube stream looking? Looks okay. Doesn't look like it's lagging out too much. Okay, so f of g of xy equals to tan e to the x minus y minus 1 minus e to the x minus y e to the 2x minus y minus x minus y squared. And the derivative matrix honestly, I would have music playing for the stream. The only problem with that is the geez, why can't I even think of the word? The copy strike and copyright laws, all that stuff. Because technically, we're not supposed to play music on streams that's copyrighted without getting permission first. Even though nobody really cares, but I mean, it does get muted when you do the playback, and I don't always want it played muted. Nothing yet. Okay, cool. X minus y minus 2x minus y. Minus 2e to the 2x minus y plus 2 times x minus y. Gonna write out that matrix. You know, I really gotta think of better ways to do it so it's neater on your screen. I mean, it doesn't look terrible. Who am I kidding? It looks pretty bad. Maybe it's just my handwriting. More practice, right, guys? And I'm just gonna write it out. Okay, taking enough time. Next question to work on. Let's see if we can make this one look better. Okay. Find the partial derivative of s. Maybe I'm gonna drop my radical down one. Partial of s of FOT at 1, 0, where f of u comma v is equal to cosine of u sine v, and t is defined by, well, t is of s of t, s and t, is equal to cosine, and so this is in a component of t squared s comma log, so this would be natural log, square root of 1 plus s squared. Okay. First, we need FOT. So FOT, that equals what? We're going to plug in T for inside F. So, cos U sine V. Well, this is our U value and our V value. So we're going to plug in cos of t squared s in for u. And the natural log of that in for v. This is going to be glorious. Okay, we've got cosine of cosine t squared s sine of natural log of the square root of 1 plus s squared. Okay. Now we want the derivative, the partial derivative of this with respect to s. Okay. Differentiate with respect to s. Well, first things first, this is a product. This is our f and this is our g. Okay, so we've got fg prime equals fg prime plus gf prime. Okay. With s and an s in here, so let's start it. F. We'll write f down. Cosine of t squared s. Done. G prime. Okay. Derivative of sine is cos. Okay. Cosine. Now we leave the inside the same. So natural log of the square root of 1 plus s squared. Okay. Now we got to do the derivative of the inside. So now derivative of the natural log is 1 over the inside. So times 1 over the square root of 1 plus s squared. And now we're still doing with respect to s, so we need to multiply by the derivative of this inside, which would be 2s. Okay, that's the first part. Now we go plus g, so the sine of sine natural log of the square root of 1 plus s squared. And now we multiply by f prime. So what's the derivative of cos? Derivative of cosine is minus sine. So we've got a minus sine. Then the inside stays the same of cosine t squared s. Then we multiply by the derivative of the inside, which is cosine of t squared s. The derivative of cos is minus sine, so minus sine of t squared s. And we got to multiply by the derivative of the inside of that. Derivative of s is just 1 because t is constant in this. Then we have to multiply that. I should make this a little nicer. Multiply that by t squared. Okay. Well, let's do a little bit of simplifying. These minus signs will cancel out. Boom, done. And that's pretty much all we can do. Now we need to plug in the point 1, 0 and see if we get the answer. What is the point 1, 0? For, what is it? T comes first? No, S comes first. So for S, we plug in 1. For T, we plug in 0. So S equals 1, T equals 0. Let's plug her in. Okay. Cosine of cosine t squared, so cosine of 0, 0. And times the cosine of the natural log of the square root S is 1, so square root of 1 plus 1, square root of 2. Okay. Divided by, well, this is multiplied by 2 times 2 over square root of 2 again. Not bad so far. Plus, now this side, sine of the natural log of square root of 2 again. Not bad. Times sine cosine of, well, this would be 0 again because t, cosine of 0. And then multiplied again by sine of 0 times, well, times 0. Oh, look at that. That's a 0. So all of this is 0. Let's see if this left-hand side becomes 0. Okay. Cosine of 0. Cosine of 0 is 1. What is cosine of 1? It's just cosine of 1. Times cosine of natural log of 2, square root 2. And, well, we can multiply top and bottom, rationalize the radical. Root 2 over 2 becomes 2 root 2 over 2, which becomes root 2. So root 2, cosine of 1, cosine natural log of root 2. Is that the answer? Well, besides the fact that I screwed up my rationalizing. Multiply by root 2. 2 root 2 over 2. They wrote 1/2. Did I screw up at 1/2 somewhere? I mean, everybody does it. Root 2 over 2. That becomes 2. And this becomes 2 root 2. So that's 2. I must have screwed up something. Natural log 1 over times derivative of s is 2s. I got root 2. And the answer says 1/2. I don't see it. Maybe when we do it again, we'll see it. Okay, let's go back to the beginning of the question. And 11. Oh, cow, we've already been on for an hour. Interesting. I wonder how everybody else's streams are doing tonight. People are on, doing their own thing. Cool, cool, cool. 11. So partial of s, well, partial of f ot 1 0, where f of u comma v equals cosine of u sine of v, and t of st equal to cosine of t squared s natural log of square root of 1 plus s squared. I guess we'll be on for a little while. And partial SFOT maybe when I write it down I'll see where that 1/2 comes in. I don't see it so far. It should be right here. What do you see? It's a little bit below. There. Instead of root 2, it should be 1/2 in front. That's what the answer says, but I don't see it. I don't know where it would have messed up. Derivative of the natural log. Derivative of sine is cos. Derivative of the inside should be 1 over square root. Ah, yes. I see it now. Haha. Silly brains. Missed the 1 freaking half. There's a 1/2 here. So this is just an S. Ha ha ha. Okay, so derivative of the this needs a little bit more. I missed this chain rule. Okay. Now we got to take the derivative of the inside, which is the square root. Which, I'll have to write it over here. This would be square root of 1 plus s squared, which would be times 1/2. Then just subtract 1 from the exponent. We'd have square root on the bottom, 1 plus s squared. Then times 2s. So we would have these two cancel out. And now we would have 2 of these on the bottom. So this is our problem. Should have square root of 1 plus s squared and then an s on top. Then it becomes just 1 plus s squared, which is where we get our 1 over 2. Ha! Knew we'd figure it out when we saw it. Brilliant! Cosine of cosine b squared s, sine of natural log square root of 1 plus s squared. We know it's product rule. Okay, writing out all this stuff. And then plus Nobody's got anything to say yet. Okay. Guys didn't even make fun of me for a mistake. Cosine times cosine of 0. Cosine natural log of root 2. That's 1/2. Sine natural log of root 2. Sine cosine of 0. Sine 0. That's 0. This equals 1/2 cos of 1. Cosine of natural log of root 2. Holy bananas. Okay. What is the next question? You know, I posted an Instagram post and people are actually commenting on it this time. And the funny thing is they're all coming up with different answers. So maybe I should just do it. No, it looks like somebody deleted their answer. Okay, I'm gonna do it. Just for a change of pace. Okay. 1 over x squared minus 1 is equal to a over x plus 1 plus b over x minus 1. This is just a partial fractions question. And we want to know what are the values of a and b. Okay. So to get this back, you have to multiply it out so that they're on the same denominator, right? So that means we'd have to have a times x minus 1 plus b times x plus 1, so that the bottom is the x plus 1, x minus 1, right? Which multiplies out to be this bottom part. Okay. So we've got, if we take this numerator and we set it equal to 1, because that's the numerator of the other part, 1 equals a times x minus 1 and plus b x plus 1. We should be able to figure out the values of a and b. Well, we've got a times x minus a plus b times x plus b. So we're going to group together these common terms and set them equal to the other side. Well, there's no x on the left-hand side, so 0, because 0 times x would be a plus b. And then we would have minus a plus b is equal to 1. So 1 equals minus a plus b. Okay. Using the first equation, a is equal to minus b. So then we'll plug in minus b for a in the second one. 1 equals minus, now a is going to be minus b. And we've got a plus b. So 1 equals, well, this is now a positive, b plus b. 1 equals 2b. b equals 1/2, which means a is the negative of b, negative 1/2. And what do these people have been writing? Well, the first person had them in reverse. They said b was minus 1/2 and a was negative and a was 1/2. This is the answer. A is negative 1/2 and b is 1/2. Hilariously, I haven't had so many people answer. Kind of awesome. Now, this other one as well. We got 2 different answers. Let's try it. Okay. I'll leave that there for a moment. Okay, so I posted this on Instagram. Sine theta is equal to 1/2. And we know that tan theta is equal to √3/3. Okay, so then we want to know what is cosine squared theta plus tan squared theta times sine theta in brackets times cotan theta squared all over cosine squared. What does this equal? And now people have different answers. One person has theta equals 30. Well, yeah, we know that. Well, knowing what theta is isn't relevant if we have these answers. What is our cosine? Well, tan is sine theta over cos theta. And we already have an answer for tan theta, and we have an answer for sine theta, so we should be able just to solve it for cos. So let's put cos on one side and tan on the other. So we'll go cos theta equal to sine theta divided by tan theta. Yeah, that's pretty true. Okay, sine theta. I don't know why I'm on a tangent. Just am. Sine theta. So we've got cos theta is equal to sine theta is 1/2 over √3/3. When you divide fractions, you multiply by the reciprocal. So this is 1/2 times 3/√3. Which would be, well, now we got to rationalize it. So √3 times √3. This becomes a 3. 3 cancels out with that. So then we have √3/2. Which is correct. Cos theta should be √3/2. Because we are actually doing pi/6 in radians, obviously. I mean, who uses degrees? Okay, we've got all our values. Let's plug it in and see what we get. Cos squared. We got √3/2 quantity squared plus tan. Tan is √3/3 quantity squared times sine, which is 1/2. Then this goes like this. We've got cotan squared. What is cotan? Cotan is 1/tan. So we'd have 3/√3 quantity squared. Whoa. Now, this is all over co squared, root 3 over 2, quantity squared. Let's simplify. Root 3 squared, that's just 3. 3 over 4. 2 squared is 4. Well, okay, this one. Root 3 squared is 3, and 3 squared is 9. 3 and 9 can be reduced to being 1/3. Times 1/2. Okay, we're going to keep that together. 3 squared is 9, and then I'll do it on this one, over 3. All over, well, root 3 squared is just 3 over 4. Okay, let's simplify further. This is a 6 and this is a 4. So I'm going to go ahead and erase this and say this is 1 over 6. We're going to change this to a 12 now. Multiply this by 3. So we got 9. And this by 2. So we'll have 11. This will be 11. 9 plus 2 is 11 over 12. Times 9 divided by 3 is just 3. Multiplied by, dividing by a fraction, multiplied by the reciprocal, 4 over 3. Look, this 3 cancels with this 3. This 4 cancels with the 12. And brings us to 3, so we should have 11 over 3. Is that what our answers are in our Instagram? Well, one person got 11 over 3. Somebody else got 9 over 2. What now, boys? Ladies and gentlemen? It's 20 to 11. Not too many people around tonight. School hasn't really started yet anyways. Plus it's, what, Monday? Yeah, it's Monday. Who does homework on a Monday night, honestly? Okay, well, this is an okay short stream. It's a good for tonight. So, what I'll do is I'll end it here. We'll find out who to just throw a host to. Let's do this. All right. I will catch you guys later.